Welcome to Cool Fire News, your source for exploring the fascinating world of electronics. I'm your host Siri, and in today's episode, we'll be diving into the fundamentals of electronic circuits, what they are, how they work, and their importance in modern technology. Let's start with the basics. What exactly is an electronic circuit? At its core, an electronic circuit is a closed loop of conductive pathways that allow electrical current to flow and perform specific functions. Whether it's powering a light bulb, transmitting data, or processing information, electronic circuits are the building blocks of countless devices we use every day. One of the fundamental components of electronic circuits is the resistor. Resistors are passive electrical components that limit the flow of current in a circuit, thereby controlling voltage levels and preventing damage to sensitive components. From simple voltage dividers to complex signal filters, resistors play a crucial role in shaping the behavior of electronic circuits. Another essential component is the capacitor. Capacitors store electrical energy in the form of an electric field, and release it when needed, making them useful for smoothing out voltage fluctuations, filtering noise, and storing charge in electronic circuits. Whether it's in power supplies, audio amplifiers, or digital logic circuits, capacitors are indispensable for maintaining stable operation. Next, let's discuss the role of the diode in electronic circuits. Diodes are semiconductor devices that allow current to flow in one direction while blocking it in the opposite direction. This property makes diodes useful for rectifying alternating current, AC to direct current, DC, protecting circuits from reverse voltage, and generating radio frequency signals. Moving on to active components, let's explore the transistor, a key building block of modern electronics. Transistors are semiconductor devices that amplify or switch electronic signals, allowing for the creation of complex circuits like amplifiers, oscillators, and digital logic gates. From vacuum tubes to silicon-based transistors, these devices have revolutionized electronics and paved the way for advancements in computing, telecommunications, and beyond. Now, let's consider the importance of understanding electronic circuits in today's digital age. Whether you're a hobbyist tinkering with DIY projects, an engineer designing cutting-edge technology, or a consumer using electronic devices in your daily life, a basic understanding of electronic circuits is essential for troubleshooting, innovation, and informed decision-making. As we wrap up today's episode, I encourage you to explore further the fascinating world of electronic circuits. Whether you're interested in analog electronics, digital logic, or microelectronics, there's always something new to learn and discover in this ever-evolving field. That concludes another episode of Cool Fire News. Thank you for joining us as we explored the fundamentals of electronic circuits. Be sure to tune in next time for more insightful discussions on topics shaping our understanding of technology and innovation. Until then, keep experimenting, keep learning, and keep pushing the boundaries of what's possible in electronics. Welcome back to Cool Fire News, your go-to source for all things electronics. I'm your host Siri, and in today's episode, we're going to shed some light on one of the most essential components in electronics, diodes. Join me as we explore what diodes are, how they work, and their myriad applications in electronic circuits. Let's start with the basics. What is a diode? At its core, a diode is a semiconductor device that allows current to flow in one direction while blocking it in the opposite direction. This property makes diodes invaluable for rectifying alternating current, AC into direct current, DC, protecting circuits from reverse voltage, and serving as voltage regulators and signal modulators. One of the most common types of diodes is the p-n junction diode. This diode consists of two semiconductor materials, one doped with electron donors, N-type, and the other doped with electron acceptors, p-type, that are joined together to form a junction. When a forward bias voltage is applied across the diode, electrons flow from the N-type material to the p-type material, creating a forward current flow. Conversely, when a reverse bias voltage is applied, the depletion region widens, preventing current flow. Now let's explore some of the key properties and characteristics of diodes. One important property is the forward voltage drop, typically around 0.7 volts for silicon diodes and 0.3 volts for germanium diodes. This voltage drop is crucial for determining the operating point of the diode and its behavior in a circuit. Another important characteristic is the reverse breakdown voltage, also known as the peak inverse voltage, PIV. This is the maximum voltage that a diode can withstand in reverse bias before breaking down and allowing significant current to flow. It's crucial to choose diodes with a reverse breakdown voltage higher than the maximum reverse voltage encountered in the circuit to prevent damage. Let's delve into some common applications of diodes in electronic circuits. One primary application is rectification, where diodes are used to convert AC voltage to DC voltage by allowing current to flow in only one direction. This is essential in power supplies, battery chargers, and audio amplifiers. Diodes are also used for voltage regulation in circuits like voltage regulators and Zener diodes, which maintain a constant output voltage despite changes in input voltage or load resistance. Additionally, diodes play a crucial role in signal modulation, frequency multiplication, and protection against voltage spikes and surges in circuits. As we wrap up today's episode, I hope you've gained a deeper understanding of diodes and their importance in electronic circuits. Whether you're a hobbyist experimenting with DIY projects or a professional designing cutting-edge technology, diodes are essential components that shape the behavior and functionality of electronic devices. That wraps up another episode of Cool Fire News. Thank you for joining us as we explored the fascinating world of diodes. Be sure to tune in next time for more insightful discussions on topics shaping our understanding of electronics and innovation. Until then, keep experimenting, keep learning, and keep pushing the boundaries of what's possible with diodes and beyond. Welcome to Cool Fire News, your ultimate destination for exploring the wonders of electronics. I'm your host Siri, and in today's episode, we'll be unraveling the mysteries of power supplies, those essential components that keep our electronic devices humming with energy. Join me as we delve into what power supplies are, how they work, and their significance in the world of electronics. Let's start with the basics. What exactly is a power supply? At its core, a power supply is a device that converts electrical energy from one form to another to provide a consistent and reliable source of power to electronic circuits and devices. Whether it's charging your smartphone, powering your computer, or lighting up your home, power supplies are the unsung heroes behind the scenes. One of the most common types of power supplies is the AC-DC power adapter. These adapters take alternating current, AC, from the main supply, and convert it into direct current, DC, suitable for powering electronic devices. You'll find AC-DC adapters in everything from laptops and televisions to kitchen appliances and portable chargers. Another essential type of power supply is the linear power supply. Unlike AC-DC adapters, which use switching regulators to convert voltage efficiently, linear power supplies regulate voltage through the use of linear components like transformers and voltage regulators. While less efficient than switching power supplies, linear power supplies are prized for their simplicity, low noise, and stability. Now let's explore the inner workings of a power supply. At its core, a power supply consists of several key components, including a transformer, rectifier, filter capacitor, voltage regulator, and protection circuitry. Together, these components work in harmony to convert, rectify, filter, regulate, and protect the incoming electrical energy, ensuring a stable and safe output voltage. One crucial consideration in power supply design is efficiency. Efficiency refers to the ratio of output power to input power, and is a measure of how effectively a power supply converts electrical energy. With a growing emphasis on energy conservation and sustainability, designers strive to maximize the efficiency of power supplies to minimize wasted energy and reduce environmental impact. Let's discuss some of the challenges and advancements in power supply technology. With the increasing demand for smaller, lighter, and more energy-efficient devices, power supply designers are constantly innovating to meet these requirements. From the development of high-frequency switching regulators to the integration of advanced control algorithms, modern power supplies are more efficient, compact, and reliable than ever before. As we wrap up today's episode, I hope you've gained a deeper appreciation for the importance of power supplies in the world of electronics. Whether you're building circuits as a hobbyist or designing cutting-edge technology as a professional, understanding power supplies is essential for ensuring the reliable operation of electronic devices. That concludes another episode of Cool Fire News. Thank you for joining us as we explored the fascinating world of power supplies. Be sure to tune in next time for more insightful discussions on topics shaping our understanding of electronics and innovation. Until then, keep experimenting, keep learning, and keep harnessing the power of electricity to fuel your imagination. Welcome to Cool Fire News, your guide to the electrifying world of transistors. I'm your host Siri, and in today's episode, we're going to explore the fascinating realm of transistors, those tiny yet mighty semiconductor devices that power our modern electronics. Join me as we uncover what transistors are, how they work, and their transformative impact on technology. Let's begin with the basics. What exactly is a transistor? At its core, a transistor is a semiconductor device that can amplify or switch electronic signals. It serves as a fundamental building block in electronic circuits, allowing us to control the flow of current and voltage with precision and efficiency. One of the most common types of transistors is the bipolar junction transistor, BJT. BJTs come in two main flavors, NPN and PNP, and consist of 3 layers of semiconductor material doped with different types of impurities. By applying a small input current or voltage to the base terminal, we can control the flow of current between the collector and emitter terminals, thereby amplifying or switching the signal. Another important type of transistor is the field effect transistor, FET. FETs operate on a different principle than BJTs, relying on an electric field to control the flow of current between the source and drain terminals. Common variants include metal oxide semiconductor FETs, MOSFETs, and junction field effect transistors, JFETs, each with its own unique characteristics and applications. Now let's explore some of the key properties and characteristics of transistors. One important property is gain, which measures the ratio of output signal strength to input signal strength in an amplifier circuit. Transistors with high gain are prized for their ability to amplify weak signals with minimal distortion or noise. Another crucial characteristic is switching speed, which determines how quickly a transistor can transition between its on and off states. High-speed transistors are essential for applications like digital logic circuits, where rapid switching is necessary to process information and perform computations efficiently. Let's delve into some common applications of transistors in electronic circuits. From audio amplifiers and radio receivers to digital logic gates and microprocessors, transistors play a vital role in countless devices we use every day. Whether it's powering our smartphones, driving our cars, or navigating the internet, transistors are the silent workhorses behind the scenes. As we wrap up today's episode, I hope you've gained a deeper appreciation for the importance of transistors in shaping the world of electronics. Whether you're a hobbyist tinkering with DIY projects or a professional designing cutting-edge technology, transistors are indispensable tools that enable innovation and progress. That concludes another episode of Cool Fire News. Thank you for joining us as we explored the fascinating world of transistors. Be sure to tune in next time for more insightful discussions on topics shaping our understanding of electronics and innovation. Until then, keep experimenting, keep learning, and keep harnessing the power of transistors to bring your ideas to life. Welcome to Cool Fire News, your gateway to the mesmerizing world of oscillators. I'm your host Siri, and in today's episode, we'll be unraveling the secrets of oscillators, those remarkable circuits that generate repetitive waveforms essential for countless applications in electronics. Join me as we explore what oscillators are, how they work, and their fascinating role in shaping modern technology. Let's start with the basics. What exactly is an oscillator? At its core, an oscillator is an electronic circuit that produces a periodic, oscillating waveform, such as a sine wave, square wave, or sawtooth wave, without the need for an external input signal. These waveforms serve as the foundation for various functions, including generating clock signals, producing audio tones, and transmitting radio frequencies. One of the most common types of oscillators is the RC oscillator. RC oscillators rely on a combination of resistors R and capacitors C to create a feedback loop that sustains oscillation. By charging and discharging the capacitor through the resistor, the circuit generates a continuous waveform with a specific frequency determined by the values of the resistor and capacitor. Another popular type of oscillator is the LC oscillator, which uses inductors L and capacitors C to produce oscillations. LC oscillators come in various configurations, including the Colpitts oscillator, Hartley oscillator, and Clap oscillator, each with its unique advantages and applications. LC oscillators are commonly used in radio frequency (RF) circuits and wireless communication systems. Now let's explore some key properties and characteristics of oscillators. One important property is frequency stability, which refers to the ability of an oscillator to maintain a consistent output frequency over time and under varying conditions. High frequency stability is crucial for applications like clock generation and frequency modulation. Another essential characteristic is phase noise, which measures the random fluctuations in phase or frequency of an oscillator's output signal. Phase noise can degrade the performance of communication systems and signal processing applications, so minimizing phase noise is a priority in oscillator design. Let's delve into some common applications of oscillators in electronics. From digital clock circuits and audio synthesizers to wireless transmitters and phase-locked loops, PLLs, oscillators are ubiquitous in modern technology. Whether it's synchronizing data transmission, generating precise, timing signals, or creating harmonic frequencies, oscillators play a vital role in shaping the functionality and performance of electronic devices. As we wrap up today's episode, I hope you've gained a deeper understanding of the fascinating world of oscillators. Whether you're a student learning the basics of electronics or a seasoned engineer designing advanced systems, Oscillators are fundamental tools that enable innovation and progress in the field of electronics. That concludes another episode of Cool Fire News. Thank you for joining us as we explored the captivating realm of oscillators. Be sure to tune in next time for more insightful discussions on topics shaping our understanding of electronics and innovation. Until then, keep experimenting, keep learning, and keep harnessing the power of oscillators to unlock new possibilities in technology. Welcome to Cool Fire News, where we dive into the electrifying world of amplifiers. I'm your host Siri, and in today's episode, we'll be exploring the fascinating realm of amplifiers, those essential components that boost the strength of electronic signals, shaping the soundscapes of our music, the clarity of our communications, and the power of our technologies. Join me as we uncover what amplifiers are, how they work, and their pivotal role in modern electronics. Let's begin with the basics. What exactly is an amplifier? At its core, an amplifier is an electronic device that increases the amplitude or power of a signal without significantly distorting its waveform. Whether it's amplifying audio signals in a sound system, boosting radio frequencies in a communication network, or magnifying voltage levels in a sensor circuit, amplifiers are indispensable tools that enhance the performance and functionality of electronic systems. One of the most common types of amplifiers is the operational amplifier, or op-amp for short. Op-amps are versatile integrated circuits that offer high gain, low distortion, and precise control over signal amplification. They can be configured in various circuit configurations, including inverting amplifiers, non-inverting amplifiers, and differential amplifiers, making them suitable for a wide range of applications. Another important type of amplifier is the audio amplifier, which is specifically designed to amplify audio signals for playback through speakers or headphones. Audio amplifiers come in various classes, such as Class A, Class AB, and Class D, each with its unique characteristics in terms of efficiency, distortion, and fidelity. Whether it's powering a home stereo system, a guitar amplifier, or a public address (PA) system, audio amplifiers are essential for delivering clear, powerful sound reproduction. Now let's explore some key properties and characteristics of amplifiers. One important property is gain, which measures the ratio of output signal strength to input signal strength in an amplifier circuit. Amplifiers with high gain are prized for their ability to magnify weak signals and drive loads with sufficient power. Another crucial characteristic is bandwidth, which refers to the range of frequencies over which an amplifier can effectively amplify signals without significant distortion or attenuation. Wideband amplifiers are essential for applications like audio reproduction and high-speed data transmission, where fidelity and speed are paramount. Let's delve into some common applications of amplifiers in electronics. From audio systems and radio transmitters to medical imaging devices and scientific instruments, amplifiers play a vital role in virtually every electronic device and system. Whether it's enhancing the clarity of a voice call, boosting the strength of a wireless signal, or amplifying the sensitivity of a sensor, amplifiers enable us to push the boundaries of technology and communication. As we wrap up today's episode, I hope you've gained a deeper appreciation for the importance of amplifiers in the world of electronics. Whether you're a music enthusiast, a telecommunications engineer, or a technology aficionado, amplifiers are fundamental components that shape the way we experience and interact with the world around us. That concludes another episode of Cool Fire News. Thank you for joining us as we explored the captivating realm of amplifiers. Be sure to tune in next time for more insightful discussions on topics shaping our understanding of electronics and innovation. Until then, keep experimenting, keep learning, and keep harnessing the power of amplifiers to amplify your world. Welcome to Cool Fire News, your portal to the world of filters. I'm your host Siri, and in today's episode, we'll be unraveling the mysteries of filters, those ingenious circuits that shape the frequencies of electronic signals, molding the sounds we hear, the images we see, and the data we transmit. Join me as we explore what filters are, how they work, and their indispensable role in modern electronics. Let's kick things off by defining what a filter is. At its core, a filter is an electronic device or circuit that selectively passes certain frequencies of a signal while attenuating others. Whether it's cleaning up noise in audio recordings, separating channels in telecommunications, or sharpening images in digital cameras, filters are essential tools for manipulating the spectral content of signals to achieve desired outcomes. One of the most common types of filters is the passive filter. Passive filters consist of passive components like resistors, capacitors, and inductors arranged in specific configurations to create frequency-dependent impedance networks. These networks selectively attenuate certain frequencies of a signal while allowing others to pass through, resulting in a filtered output waveform. Another important type of filter is the active filter. Active filters incorporate active components like operational amplifiers, op-amps, or transistors to achieve frequency-selective amplification or attenuation. Active filters offer advantages such as high gain, low noise, and precise control over frequency response, making them ideal for applications where performance and flexibility are paramount. Now let's explore some key properties and characteristics of filters. One important property is cutoff frequency, which defines the boundary between the passband and stopband of a filter. Cutoff frequency determines the transition between attenuating and passing frequencies, and is a critical parameter for specifying the performance of a filter. Another crucial characteristic is filter order, which quantifies the steepness of the filter's frequency response curve. Higher-order filters have steeper roll-off slopes and provide greater attenuation of unwanted frequencies, but may also introduce phase distortion and require more complex circuitry to implement. Let's delve into some common applications of filters in electronics. From audio equalizers and graphic equalizers to radio frequency, RF filters and image processing algorithms, filters are ubiquitous in a wide range of devices and systems. Whether it's shaping the tonal balance of a music track, isolating signals in a wireless network, or enhancing the clarity of an image, filters are indispensable tools for tailoring the characteristics of electronic signals to meet specific requirements. As we wrap up today's episode, I hope you've gained a deeper appreciation for the importance of filters in the world of electronics. Whether you're a musician sculpting sounds, a photographer refining images, or an engineer optimizing data transmission, filters are powerful tools that enable creativity, precision, and innovation in electronic design. That concludes another episode of Coolfire News. Thank you for joining us as we explored the captivating world of filters. Be sure to tune in next time for more insightful discussions on topics shaping our understanding of electronics and innovation. Until then, keep experimenting, keep learning, and keep filtering out the noise to reveal the beauty of the signals around you. Welcome to Coolfire News, your window into the world of integrated circuits. I'm your host Siri, and in today's episode, we'll be exploring the fascinating realm of ICs, those tiny but powerful electronic devices that have revolutionized the way we live, work, and communicate. Join me as we uncover what integrated circuits are, how they work, and their profound impact on modern technology. Let's start with the basics. What exactly is an integrated circuit? At its core, an integrated circuit is a miniaturized electronic circuit consisting of interconnected semiconductor components, such as transistors, diodes, and resistors, fabricated on a single semiconductor wafer or chip. By integrating multiple components onto a single chip, ICs offer compactness, reliability, and performance advantages over traditional discrete circuits. One of the key innovations that paved the way for integrated circuits was the invention of the transistor in the 1950s. Transistors replaced bulky vacuum tubes with compact semiconductor devices, making it possible to pack thousands, or even millions of them onto a single silicon chip. This breakthrough laid the foundation for the development of integrated circuits and sparked a technological revolution that continues to this day. Now let's explore some of the key components and features of integrated circuits. One essential component is the silicon wafer, which serves as the substrate for fabricating semiconductor devices. Silicon wafers undergo a series of intricate processes, including doping, etching, and metallization, to create the intricate network of transistors and interconnects that comprise an IC. Another crucial feature of integrated circuits is their architecture, which can range from simple digital logic gates and memory cells to complex microprocessors and system-on-chip (SoC) designs. IC architectures are tailored to specific applications, offering optimized performance, power efficiency, and functionality for tasks ranging from arithmetic calculations to wireless communication. Let's delve into some common types of integrated circuits. Digital ICs, such as microcontrollers and field programmable gate arrays, FPGAs, process binary data using logic gates and flip-flops to perform tasks like computation, data storage, and signal processing. Analog ICs, such as operational amplifiers and voltage regulators, manipulate continuous signals to perform functions like amplification, filtering, and regulation. Now let's consider some of the applications of integrated circuits. From smartphones and computers to automotive systems and medical devices, ICs are omnipresent in modern technology. Whether it's powering our electronic gadgets, controlling industrial processes, or enabling space exploration, integrated circuits are the backbone of the digital age, driving innovation and transforming the way we live and work. As we wrap up today's episode, I hope you've gained a deeper appreciation for the importance of integrated circuits in shaping the world of electronics. Whether you're a student studying semiconductor physics, an engineer designing cutting-edge technology, or a consumer enjoying the latest gadgets, integrated circuits are fundamental to our interconnected, high-tech world. That concludes another episode of Cool Fire News. Thank you for joining us as we explored the captivating world of integrated circuits. Be sure to tune in next time for more insightful discussions on topics shaping our understanding of electronics and innovation. Until then, keep experimenting, keep learning, and keep harnessing the power of integrated circuits to drive progress and change.